Hello viewers, welcome to my channel and thank you for watching the videos. In this video, question 5C of 1995 UPSC CSC Maths Optional Paper 2. Here question is, let C be a circle mod z is equal to 2 oriented counterclockwise. Evaluate the integral C cos hyperbolic pi z upon z into z square plus 1 dz with the aid of residues. So we know the formula of residues for finding the integral, that is equal to 2 pi I into sum of the residues at the poles inside this contour, which is mod z is equal to 2. So first we will find out the poles. Poles are, putting denominator equal to 0 is z is equal to 0, and second is z square plus 1 is equal to 0, which will give z square is equal to minus 1. So z is plus minus I. So here contour is mod z is equal to 2. So these poles which are z is equal to 0, z is equal to plus I, z is equal to minus I, all three lie inside this contour. So we have to find out residue at these points. So let's just do. We know the formula of finding residues. So here we have this formula. Integrand is cos hyperbolic pi z upon z into z square plus 1. So formula is limit z tends to 0, z minus the pole value, that is z0 we say, which is here 0. So z minus 0 is z. Cos hyperbolic pi z upon z into z square plus 1. So when we put this is cancelled out, cos hyperbolic pi 0, that is cos hyperbolic 0 is 1. So in numerator 1 upon 0 plus 1. So this comes 1 when we are taking this limit tends to 0. Now second pole is z is equal to I. So the formula is same, limit z tends to z0, that is z0 is I. Here z minus z0. Z minus z0 is z minus I. Cos hyperbolic pi I in place of z I upon I into I square plus 1. So I square is here. So this will give 0 in denominator. So instead of doing that, we will multiply numerator and denominator both with z plus I. It will give z minus I into z plus I is z square minus I square, which is z square plus I square. So in denominator and numerator both will be cancelled out. Z square plus 1 will cancel out. And now in denominator the term is remaining, that is z into z plus I. And when we put z is equal to I, it gives 2I. So we get this term, which is cos hyperbolic pi I and upon I into 2I. So in short, what we did, directly we didn't put the value z is equal to I. First we have multiplied with z plus I in numerator and denominator, and after simplification we have kept the value of z as I. So this is minus cos pi upon 2. So this I square is giving minus cos hyperbolic pi I is equal to e to the power I pi plus e to the power minus I pi upon 2. And we know e to the power I pi plus e to the power minus I pi is equal to 2 cos pi. Or we can say cos pi is equal to e to the power I pi plus e to the power minus I pi by 2. So ultimately this is equal to cos pi. And in denominator we got 2. So this comes cos pi is minus 1 minus minus plus 1 by 2. Now we take residue at this is limit z tends to I, z plus I cos hyperbolic pi z upon this much. So here again we will multiply by z minus I in numerator and denominator. Z square minus I square. So this gives, as earlier it was cancelled out, same thing will happen here. And in denominator it will be minus I and minus 2I in place of I and 2I, and cos hyperbolic minus pi I, which is equal to, in place of pi we will put minus pi and the formula will be same, because it becomes e to the power I pi plus e to the power minus I pi by 2, and that is cos pi upon 2. It comes cos pi, which is minus 1, and in denominator it is again 2I square, which is minus 2. So this is 1 by 2. So we use the formula 2 pi I, use the formula 2 pi I into sum of residues at poles of the integrand inside C.